Hello everyone. In this session we will learn about object-oriented programming in Python. We will learn about classes and objects and how to use them in Python. What is object-oriented programming? Object-oriented programming or OOP concept is a programming paradigm based on objects and classes. It helps in organizing code, reusability, and structuring complex programs efficiently. It's a programming model where we design programs using real-world concepts like objects and classes. In this module, we will learn about classes and objects, how to create blueprints for objects, and how to create actual object instances, attributes and methods, understand how data is stored within objects and how objects use methods. Inheritance. Learn how new classes can inherit behaviors from existing classes, promoting code reuse. And lastly, polymorphism and encapsulation. Learn how polymorphism allows for flexible code and how encapsulation hides the internal details of objects. What are classes and objects? A class is like a blueprint or a template for creating objects. Think of it as a car blueprint. It defines the structure, features, and functionality of a car, such as the number of wheels, engine type, and color options, but it doesn't create an actual car. An object is an instance of a car. An object is an actual car built using a blueprint. Each car has the properties defined in the blueprint, but can have different values, like a red Ferrari or a blue BMW. Let's understand this with the help of an example. As we learned earlier that in object-oriented programming, a class is like a template or a blueprint for creating objects. In this example, the car class represents a general category of cars and defines common attributes that all car objects will have. From the diagram, the car class has at least three attributes. Wheels, the number of wheels that the car has, example 4. Engine, the type of engine, for example hybrid or petrol, and the color of the car, example blue or red. All cars share these attributes, but their values can be different for each specific car object. Next, we have created two car objects based on the class car, BMW and Ferrari, that inherit the properties from the car class. Each object has unique attributes and may have additional properties. For example, for the BMW object, we have the attributes wheels as 4, engine as hybrid, color as blue. Then we also have an additional attribute number of seats as 2. For the Ferrari object, we have the number of wheels as 4, engine is of type petrol, it has the red color, and there are two additional attributes, number of gears, which is 9, and speed, 350 km per hour. While both objects originate from the same car class, they have different values for their attributes, with BMW having one additional attribute as number of seats and Ferrari having two additional attributes, gear and speed, showing that objects can have additional attributes beyond the base class. Now let's see this example in code. First, we'll create a new Python file called classes. Now let's create the car class. Class car colon. The class keyword is used to define a class. Let's create a constructor method for initializing the attributes of the car class. Def to initialize the function, then underscore underscore init underscore underscore, then as parameters self, wheels, engine, and color. Here car is the class with the attributes wheel, engine, and color. The init method initializes these attributes to be used by the objects. To initialize these attributes, we write self.wheels equal wheels, self.engine equals engine, and self.color equals color. These statements assign the value of the attributes to the instance attribute itself. For example, self.wheels equal wheels assigns the value of wheels to the instance attribute self.wheels. The self keyword ensures that each object of the car class gets its own copy of the wheels, engine, and color attributes. Now we create a method to display these attributes. Def display underscore info and self as parameter. Print car wheels, comma, self dot wheels. Print car engine, comma, self dot engine. Print car color, comma, self dot color. If self is not used, Python would not know which object's brand or color we are referring to. Self is important because it ensures that each object maintains its own attributes. It allows methods to access and modify object-specific data, and it differentiates between instance attributes and local attributes. Now let's create two objects for the car class. BMW equals car, and then within braces 4, comma, hybrid, comma, blue. This will create a car object called BMW with the attributes for wheels as 4, engine as hybrid, and color as blue. Similarly, we create another object as Ferrari equals car, and then within braces 4, comma, petrol, comma, red. Now let's use the display info method with these two objects to see the attributes. BMW.displayInfo and Ferrari.displayInfo. Now when we run the code, we see that the class attributes for both BMW and Ferrari are displayed. BMW has 4 wheels, hybrid engine and blue color, whereas Ferrari has also 4 wheels but petrol engine and red color. Now, how do we add the additional attributes for these two objects BMW and Ferrari? For BMW, we have the additional attribute seat equals 2. So we write BMW.seats equals 2, and for Ferrari, we have Ferrari.gears equal 9 and Ferrari.speed equals 350. Now, if we want to use these attributes, we can call them similar to the creation. So the first statement will print the value of seats for the object BMW. And the second statement should print the value for gears and speed attributes for the object Ferrari. Now when we run the code, we see that the additional attributes for BMW and Ferrari are also shown. For BMW, seats 2, and for Ferrari, gears 9 and speed 350 km per hour. Python has also something called instance attributes and class attributes. In our example, the attributes wheels, engine, and color are all instance attributes as they can be different for different objects. Let's define a class attribute and see the difference between class attributes and instance attributes. In our class, let's create a new attribute outside the init method. Location equals Europe. What this does is, both the objects BMW and Ferrari will get the object location as Europe without explicit declaration. If we display this as print location BMW, comma, BMW.location and print location Ferrari, comma, Ferrari.location. And run the code, we get location BMW is Europe and location Ferrari is also Europe. We did not have to initialize the values of location for BMW and Ferrari while creating the objects BMW and Ferrari. So the attribute location is class attribute, while the attributes wheels, engine and color are instance attributes since they are used to define different instances of the same object of the class car.